Hello. Yeah, good evening. How are you? Yeah, yeah, for me it was a good day. Had you had your tea and snacks? Oh, everything done, isn't it? Okay. What? No, no, it's not like that. I usually had my tea and snacks after the class. I'm not a fan of tea. I don't like it too much. So most of the days I skip it. But there are days when I'm in too much pressure or heavy headache and all, I used to have a small cup of tea. Yeah. No, no, it's not like that. Actually, my mom said that I'm a fan of tea in my childhood days, that is up to 5 years. And then later, me by myself has become um, somewhat negative form to tea. Yeah, it's like that. Okay. So you are a great fan. Okay. For me, if someone else, which one you like? Is it tea or coffee? I will surely say it will be coffee or boost Horlick, something like that. And yeah, it's that I'm not avoiding caffeine. I'm a fan of coffee, but in these, I prefer boost or Horlicks. Yeah, I do do it. That is having tea with cookies. Yeah, yeah, I allowed to have tea in once in a while I told. But I'm not a man that needs tea at perfect time in the morning, in the evening, like that. Yeah. Yes. Are you done with your work? Were you able to sort it out? What happened? Okay. Okay, that's fine. That comparing quantities part. Your, I think all other portions are completely okay for, isn't it? So let me discuss that other part of discounts once more in the next class, okay? Yeah, of course. It's fine. Yeah, yeah, I don't want to make it full. Yeah, we can discuss it once more. And I want to make sure that you are completely thorough in this. Okay, when you guys are having exam test or day after tomorrow? So, I think like today, let me continue with surface area volumes. And I would like to spend tomorrow's class for combined quantities itself. So yeah, from the top to bottom, I like to discuss. Yeah, pressurizing that discount part. So it will be much more clear to you, isn't it? Of course. Okay, it's fine. So yeah, shall I go to the chapter? Shall I go to lesson plan? I have actually created a lesson plan for you for the chapter surface area volume. Are you interested in it? Okay. So will you please see any three 2D shapes you see in your life or that you come across in your life? Yeah, yeah, you can choose. Very good. Yeah, that is square, rectangle, triangle, pentagon, hexagon. Yeah, that line goes on, isn't it? So what about 3D shapes? What is the basic difference between a 2D as well as a 3D? Oh, very good. Yeah, correct. 2D will be flat one, while the 3D will be a 3D mode. Yeah, yeah, correct. So let's imagine our Rubik's cube. Yeah, we have cubes, cuboids, spheres, cones, cylinders, pyramids, prisms, and all in 3D mode. Yeah. So you know one thing. Today, in this chapter of surface area and volume, we are going to deal with these shapes. Yeah, the shapes I mentioned now. And what we are going to deal, we are going to deal with its surface area as well as volume. As the topic of the chapter, the name of the chapter says is, we are going to deal with the surface area and volume of different kinds of shapes. Yeah. So shall I? Or did you get a basic idea of it? course. Okay. Thank you, dear. Yeah. So today we are going to start a new chapter, surface area knowledge. Topics to be covered here are surface area of a combination of solids or a compound shapes, volume of combination of solids. That is, sometimes a shape will become as a combination of too many shapes. Did you get me? Yeah. We usually call it as compound shapes. They are naming it as combination of solids. Okay. So for that time, so let me give an example. I have a little daughter. I said, yeah. Her name is Hava. Yes. So, I just bought a good toy, a new toy for her. It has a cylinder part in the top as well as a hemisphere in the top, in the bottom. Towards the bottom, it's a hemisphere, while on the top part, it will be a cone. Did you get that shape now? Yeah, of course. So it's combination of solids, isn't it? For that, if the question is to find its surface area or volume, if the radius of the hemisphere is known, or the height of the cone, L of the cone is known, we can easily sort it out. We can find the surface area and volume of the cone. Sorry, not surface area and volume of the new toy. Of course. So I'm planning to paint the whole part of that, paint the surface area, paint the curved areas of those a new toy. I want to know how much area will it be. Before painting, I want to get a small idea about it. For knowing how much time will it takes for me to paint that whole surface. So if I got the surface area of the toy, it will be quite easy for me to calculate the time, isn't it? Yeah, yeah, that's so that's surface area and volume. And learning objectives are understanding key terminologies. What is base, height, lateral surface area, total surface area, volume. Do you know curves of area? CAC? Yeah. Lateral surface area is same as curved surface area itself. Yes. Learning formulas for cubes, cuboids, cylinders, cones, spheres. Oh, these are the shapes we are going to discuss here. Cube, cuboids, cylinders, cones, spheres, and mostly hemisphere will also be there. I think we don't have to go to pyramids and prisms. Yeah. Applying formulas to solve real life problems, developing solving skills in geometry, enhancing spatial visualization abilities, recognizing dimension, surface area, or volume relationship, practicing calculations with proper unit usage. Okay. So prior knowledge we require, the basic knowledge you need are shapes, measurement. Yeah, it's fine. So I'm going to surface area part. Okay, I think cuboid is a rectangular mod. It's a 3D shape of rectangle, isn't it? Yeah. And what about cube? Do you know what's the 2D shape of a cube? Square. Very good. Square, when we represent it in a 3D mod, it will become a cube. Yeah, Rubik's cube. Because one of the face of the Rubik's cube is completely a square, isn't it? Yeah. Triangle. Triangle is a 2D shape, and its 3D form we can just represent it as a cone. It's somewhat like a cone, isn't it? Yes. Circle. Circle 3D shape is sphere. Yes. Yeah. And I think these equations and formulas are completely okay for you, isn't it, dear? What's the name of rectangle? Yes. What about square? Triangle? Circle. What is radius? If the question they have given us the diameter of the circle, how can we calculate the radius from it? Yeah, diameter is equal to 2 into r, 2 into radius. So radius is equal to diameter divided by 2, is it? Okay. In the class 8 9, we just entered to 3D solids. In cube, all sides are equal with a volume formula of side cube. Yeah, for finding the volume of a cube, that is a cube. A cuboid is a 3D rectangle. Yeah. The volume is equal to length into breadth into height. For example, yeah. This is a cuboid. We have length here, breadth here, height here. For finding the volume of this cuboid, we should multiply length into breadth into height. Is it fine? Okay. Okay, dear. And cylinder or sphere. It's a round 3D object. It's a 3D form of a circle. Its volume is equal to 4 by 3 pi r cube, where and its surface area is 4 pi r square. Don't need to worry. I'll go to these equations and formulas in detail. Okay. Cylinder is pi r squared is its volume, as well as surface area is 2 pi r into h plus r. Okay, that's all. In Pythagoras theorem, we know hypotenuse square equal to base square plus altitude square, opposite square. Is it fine? Yeah. Okay. Now we are moving on to the surface area formulas for some shapes. Yeah. We have got a cube here. Its lateral surface area. Okay, let's just see what's the major difference between a lateral surface area, or a curved surface area, and its total surface area. Yeah, yeah. For the lateral surface area part, we are mentioning only about that four phases. Okay, we are just skipping the top and top as well as the base or bottom. Did you get me? Curved surface area. We are just looking for that only four phases there. Yeah. So for one side it is a square, isn't it? A of a square is equal to a square. So what will be the four sides? 4a square. What about the total surface area? We should add top as well as the bottom. Then it will become 6a square, isn't it? Did you get me? Okay. So here we have, when we are discussing about the lateral surface area, we have only 2h into L plus P. And for the total surface area, we have all the parts. And every part is repeating twice, isn't it? LB, LH, and BH part is repeating twice. Yes. And this is a cylinder. CSE is equal to 2 pi RH. Should completely by heart this equation, okay? 2 pi RH. Its volume is pi r square h. And the total surface area is 2 pi r into r plus h. Did you get that? I don't want to compel you to study the total surface area, but you should be thorough with curved surface area of every shapes. Yeah, it is 2 pi r here, isn't it? So if you want to find the total surface area here, we know that they are just dealing with curved surface area this part only. We should add the top as well as bottom there. If the CSA is 2 pi RH, 2 pi RH, we should add 2 pi r square also, isn't it? Because the top as well as the bottom is in circular part. So what's an area of circle? Pi r square. We have to add top as well as bottom there. So it will be 2 pi r square, isn't it? So yeah. So when we are adding this, I'm taking 2 pi r as common from this part. Then what is remaining here? H plus r. So 2 pi r into h plus r plus h. This is the equation for finding the total surface area of a cylinder. I think it's okay for you, isn't it? Yeah. And we are moving on to cone. Similarly, we should by heart the surface area of the cone, curved surface area of a cone or lateral surface area. Pi r l. Pi r is the radius and l is the length. No, no, yeah, it's not a height. Height is what's in the perpendicular form, and length is in the slanting form. That is, I'll show you. This is the L here. Okay, this is L here, and H is this part. You just imagine an ice cream cone here. Okay, yeah, that L, this slanting portion is L, and height is at perpendicular one. Okay. So CAC is, we know that it's pi r L. If you are to find the total surface area, we should add this base part also. That is pi r square, isn't it? Area of a circle. Pi r plus pi r square. I'm just taking pi r is common from here. Then the remaining is L plus L. So this is the formula to find the total surface area. And every time we should properly put the dimensions. Okay. Yeah, centimeter square. Every time the area will be in the square mode, volume will be in the cube mode, okay? And the perimeter will be just the dimension itself. Yeah, centimeter, meter, kilometer itself. Of course, yeah, you're right. And we are moving on to the sphere. Does sphere have two kinds of surface area, that is curved and total? Do you think so? Is there is any top and bottom for a sphere? Yes, no, we doesn't have any top and bottom. It's just a circular mode of 3D sphere. 3D, yeah, circular mode of 3D. Yeah, that is. So for the equation, 4 pi r squared. You just by heart the equation. I don't have any other option for it. Of course. And when I'm moving on to the hemisphere, we have core surface area as well as total surface area, because this can be divided into two, isn't it? This way is this partly divided. We know that the total surface area of a sphere is 4 pi square. Then what will be the surface area of a hemisphere? Yeah, of course, 4 pi square divided by 2, it will be 2 pi r square. That is the 2 pi r square given here. And we know that 2 pi r square is its curved surface area. For finding the total surface area, we should add one more pi r square, isn't it? Because let's end up at that cut, that the part where the cut has been take place. Yeah, of course. So that is 2 pi r square. That is equal to 3 pi r square. Is it fine? Okay. No, we have pyramids and all, pyramid prisms and all here. This is a pyramid. We have, uh, yeah, this is a pyramid here. And I think you know what pyramid is. Is okay, okay. Yeah, the base of the pyramids kept on different, isn't it? And for finding the lateral surface area means we are just ignoring, neglecting the base part. Yeah, that we can be calculated by half into base perimeter. We are not sure in which shape that perimeter is occurring. It can be a triangle, it can be a square, it can be a rectangle. Okay, so base perimeter, just add the sides of the base into slant height. Okay, yeah. And for finding the total surface area, we should add this LSA, plus we should find the area of the base also. If it's square, it's a square. If it's a rectangle, it is L into B. If it's a triangle, it is half into B into H. Okay. Yeah. And prism. Do you have seen prism anywhere? Yeah. Yeah, in a physics lab, isn't it? To study reflection. Is it so? Guys. I think that was the first time you were seeing a prism by yourself. Yeah. Do you like physics? To study reflection, refraction, retraction at all? Okay. Okay. Yeah. No, don't say that. Actually, physics is good. Yeah. No, no. Math is actually very much easy and quite interesting. But physics also is nice. It's somewhat a branch of math itself. Isn't it? With many more calculations into speed equal to distance into time. Yeah, yeah, many equations, formulas into. Which is your favorite subject about science? Biology. Yeah, theory. You're focused on the theory part. So yeah, practicals are also interesting. But as it for for the chemistry and physics, we have many much equations to balance, many more formulas to by heart. Is it so? So biology is something we can just read and study. And the practical classes are also interesting. Dissection at all, isn't it? We have a live cockroach in your hand, just dissected live frog. Is it so? Yeah, this the simplicity. No, no, you just plan to take science itself for your high classes. Yeah, it's super. Really, dear. Yeah. Okay. Shall I move to prism? So it's a prism here. The lateral surface area can be found. So prism is also the same case. Uh, we have many different kinds of prisms here. That is triangular prism, rectangular prism, square prism, etc. I think you usually seen triangular prism, isn't it? This the one which is in the textbook. Yeah. Lateral surface area is equal to base perimeter into height. Similar as what? Pyramid, yeah. And total surface area is LS into plus 2 into area of base. Okay, don't forget that. For the last term of pyramid, we don't have two bases here. We have just only one base. But for the prism, we have a top as well as a bottom here. So we should multiply the area of base with 2. Okay. So so shall we try to do this question? Yeah. We have got a cube here, cube with 5 centimeter as its side, and a hemisphere is kept just in its top. Yeah, it's a decorative block, and it consists of two solids here. Cube with edge 5 centimeter and hemisphere with diameter 4.2 centimeter. We are supposed to find the total surface area of the block, isn't it? And they asked us to take pi equal to 22 by 7. So, first of all, you should take the total surface area of the cube, and then we should calculate the surface area, total surface area of the uh sorry here there is no need of calculating the total surface area of the hemisphere, because that base part is already calculated in the cube, isn't it? So we should go upon the lateral surface area of the hemisphere. It will be 2 pi r squared. So shall I try to do it in one out? Of course, yeah. What should we speak? Yeah, it's 11 hours. And the question is, they have provided us with a cube in the down part. Actually, my drawings are not so good. I'm not drawing, okay? So you should just cooperate with me. Yeah. Let this be a cube. And it's something, this looks like a cuboid, isn't it? So just keep in mind it's a cube. Don't, yeah. Okay, don't get confused. And I'm just sketching a hemisphere in its top. Just okay, it's a hemisphere in its top, and you're supposed to find the total surface area of this this decorative block. Okay, as per my as per my calculation, I think we can first find the surface area of this sphere, and just okay, that is first yeah, given that edge is equal to 5 centimeter and the diameter is equal to 4.2 centimeter, isn't it? Yeah. So, cube, and the surface area of cube is equal to a cube is equal to 5, isn't it? Isn't it here? Yeah. 5 is a 25, 25 into 5 equal to 125 centimeter cube. We got the total surface area of the cube here, and now I'm going to find the CSA of hemisphere. Isn't it? CSA of hemisphere is equal to 2 pi r square. 2 pi r square. So that is 2 into 22 by 7 into, is it 4.2? Yeah. 4.2 into 4.2. And 7 6 are 42, isn't it? 7 7. So let me write here as 0.6. Is it fine for you? Yeah. It will be 22 into 2. 44 into 42 into 0.6. 4 2s are 8. 4 2s are 8. That is 0.8. I just want to multiply 8 into 44 here. 4 8s are 36. 4 8s are 36, 37, 30, 32, isn't it? Yeah, 32, 34, 34, 35. 8 was a 32, 32, 33, 34, 34, 2, 7, 5, 6, 7. It will be 38.72 centimeters square. Okay. This is the surface area of the hemisphere. But we have got a little more task to complete. Yeah, while we take the total surface area of the cube, we had just calculated the base part of the sphere also, isn't it? Now it's our responsibility to subtract it from the cube, isn't it? Yeah, for taking the whole surface area of the two of the decorative block, that part is an extra, isn't it? Yeah, of course. So I'm just going to uh I'm trying to find the surface area of that area of that circle part. It's equal to pi r square, isn't it? By 22 by 7 into 4.2 into 4.2. Similar to what I did right now. 0.6. 22 into 0.88. Then that will be 8 into 22. 2 8s are 16. 2 8s are 16, 17. 2 8s are 16. 2 8s are 16, 17. 6, 12, 13, 7, 8, 9, 1936, 19.36, isn't it? Centimeters square. So I'm just trying to do the calculations. First of all, we want to add the surface area of decorative block is equal to total surface area of cube plus surface area of hemisphere, and from this two we should minus surface area of that base of hemisphere, of base hemisphere, hemisphere base. Okay, so that will be 125 plus 38.72 minus 19.36. So let me do the calculation here. Yes. 6 here and 12, 6 is 3, 4, 5, 6, 3, 2 here and it will be 18, 9, 19.36, 125 plus 19.36, 0.36, 5, 14, 2, 3, 4, 144.36. Centimeter square is the total surface area of that decorative block. Did you get me? If you want, you can just go through this once more. Yeah. Yeah, for finding the total surface area of that decorative block, I just find the surface area of the cube, total surface area of the cube first, then find the curved surface area of the hemisphere, and then I just subtracted that extra part from it, isn't it? Hence, I got the answer as 144.36 centimeters square. Okay, I think it's clear too, isn't it? Okay, then let me. So I think that's enough for today's class. So let me stop my presentation. Yeah, okay. See you. See you on last day. See you tomorrow. Bye.